Hello, this is Miss Igo. Welcome to my classroom. Today we're going to talk about graphing compound inequalities. A compound inequality is an inequality that combines two simple inequalities. And if you'll remember, an inequality is a statement that has the symbols less than or equal to, greater than or equal to, not an equal sign because that would make it an equation. For each compound inequality, give the solution set in both interval and graph form. Well, before we graph this combined inequality, let's talk about the simple inequalities. We have x is less than 2, and we have x is greater than or equal to -3. So first of all, if we were going to graph just x is less than 2 on the line, there's a couple of things we would need to know. X is less than 2, so that means we would need all the numbers that are to the left of 2. It's less than 2. And then it's also just less than 2. 2 is not included. So if we have the symbols less than or greater than, not equal to, then on our number line, we are going to use parentheses. If we have less than or equal to, or greater than or equal to, then we would use brackets on our number line. And the way that I remember which one goes with which, if you see the straight line underneath your inequality symbol, the equal to part, then let that remind you of the straight line in your brackets. So if it's less than or equal to, greater than or equal to, you see that straight line, you're going to use brackets. If it's just less than, just greater than, you don't see a straight line, so you're going to use the parentheses. Okay, so when we're combining these inequalities, notice that it says and. So and represents the intersection, or only the part of the graph that overlaps. Well, before we can see what overlaps, we need to see what the two graphs look like separately. So I'm going to not put these separate ones on the line. I'm going to hover them above or below the line. And if I have x is less than 2, again, like I said, since it's just less than, not less than or equal to, I'm going to use a parenthesis on the number 2, and it's less than 2, so it's all the numbers less than 2, so that's going to go to the left. Okay, so there's a couple of ways that you can remember what direction you need to do your arrows. First of all, it's less than, so that's all the numbers less than, but you can also think of your inequality as an arrow. So if you'll notice, that inequality symbol looks like an arrow pointing to the left. For our x is greater than or equal to 3, it looks like an arrow pointing to the right. So you can draw your arrows going to the left or the right depending on what your inequality symbol is, but you can only use that cheat if your variable is first. So if your variable is not first, for example, if it was x is greater than, 2 is greater than x, you would not be drawing your arrow to the right because the x is not first. You would have to flip everything and write it as x is less than 2. We're flipping it, and then you can go the direction that the imaginary arrow is pointing. Okay, so then for the other part of our compound inequality, x is greater than or equal to -3. On -3, I'm going to put a bracket because we have the equal to part, that straight line that reminds me of the bracket. And then we have our inequality, x is greater than, that means all the numbers greater than -3, so that's going to go to the right. But we can also look at this as an arrow pointing to the right, so it tells me it's going in this direction. Now, this is a compound inequality. This says and, so it's only going to be the parts of the graph that overlap. So if I look at what's overlapping, it starts overlapping here at -3, and it stops overlapping here at 2. So the only thing that's going to be on my graph of the combination of these two inequalities is the part from -3 to +2. And to enclose that line, I'm going to use whichever line ends on that number. So this top one that I have, that x is less than 2, it doesn't end on -3, but the bottom one ends on -3. So that bracket is what is on -3. And then the top line is what ends on 2, and it's a parenthesis. So the parenthesis is going to go, did I say -2? It's going to go on the +2. Now, to write my interval, I'm going to look at what I have on the graph. So just the red part, that is what the actual answer is for the compound inequality. So this green part, let's take it away. That was just a sketch to help us know what parts overlap. So this is the graph form of this compound inequality. And now we're going to write the interval form. So I can look at the graph to help me know how to write the interval. So my interval is going to start, my interval always goes from left to right. So I'll look at the lowest or the leftmost number, and that would be -3. And on -3, I have a bracket, so that's what I'm going to enclose my interval with. So I have a bracket, -3, and it goes to 2, and I'm going to enclose that with a parenthesis. And that's how I would write my interval form of this compound inequality. Now, this is using the same two simple inequalities, but the connecting word between them is or. So that makes a difference. When it's and, it's only the part that overlaps. But when our connecting word is or, that means we're going to include everything that's in both of the separate inequalities. So if I look at these two inequalities separately again, I have x is less than 2, so we have a parenthesis on 2, and it's less than 2. And then x is greater than or equal to -3. So we start at -3 with a bracket because greater than or equal to, and it's all the stuff greater than. Go to the right. Now, since the connecting word is or, that means anything that's in either line. We're just going to put our two lines together. So if we were to put these two lines together, everything that's on both lines, then it goes all the way to the left forever. And then if I put this line up here, this goes all the way to the right forever. So we don't stop. We don't put these brackets or parentheses or anything on the line. It's just like we put the two lines together, join the two lines together, and that covers all the numbers to the left and all the numbers to the right, and they overlap. So it would just be all the numbers on the number line, which means our interval would be from -infinity to +infinity. Now, we never enclose infinities using brackets. It's always going to be parentheses. For a bracket, the bracket means that that number is included in the solution. Well, infinity is not a number. It continues on and on. So it's always enclosed in parentheses. Before we can graph these separate inequalities, we have to solve them first. And to solve an inequality, that means that we want to isolate the variable or get the variable by itself. So if I look at this first inequality, -3x is less than 3, I need to divide by -3 in order to get the x by itself. Well, if you'll remember the rule, whenever we're multiplying or dividing both sides of an inequality by a negative number, then we have to flip the inequality symbol. So I get x is greater than -1. And then for the other inequality, I'm going to subtract 2 from both sides, and I get x is less than 4. Okay, so the other thing that we need to pay attention to is our connecting word. So our connecting word is and, which means we're going to be graphing only the parts of the graph that overlap. So if I look at these two graphs separately, x is greater than -1. So we start at -1 and it's all the numbers greater than -1, which would be to the right. Or again, I can just look at the fact that my variable is first. So this looks like an arrow pointing to the right. So it's all the numbers to the right. This is just greater than, not greater than or equal to, so it would be a parenthesis on that number. And then x is less than 4. So again, it's just less than, not less than or equal to, so it's a parenthesis, and it's all the numbers to the left, all the numbers less than, or I can follow that arrow going to the left. Now, if I only graph the part that overlaps because the connecting word is and, then our two graphs start to overlap at -1. And they overlap each other until they get to +4. And again, we use whatever symbol for the line that ends on that number. And this top graph ends on -1 and it has a parenthesis, so we're going to put a parenthesis on -1. The bottom line ends on 4 with a parenthesis, so we're going to enclose it with a parenthesis. So our interval form, again, we're only looking at what's on the line, that red part, that's my answer. And my interval is going to go from -1 to +4, and we're going to use these parentheses to enclose our interval. -1, +4. All right, let's look at this one. We have 3x is less than x plus 12, or x plus 1 is greater than 10. So before we can graph anything, we need to solve the inequalities. And in this first inequality, I want to isolate the variable. So first I need to get both x's on the same side. And remember, if we want to get to use the trick where we can follow our inequality like an arrow, we want to get our variable on the left side. We want to have it first. So I'm going to move this x over to the other side by subtracting it. And that gives me 2x is less than 12. And then to solve that, I would divide both sides by 2. And here I would not flip the inequality because I'm not dividing by a negative. Okay, so that gives me x is less than 6. Then for the other inequality, I'm going to subtract 1 from both sides. So that gives me x is greater than 9. Okay, our connecting word is or, which means we're going to graph everything that's in either graph is going to go together for our union of our graphs. So I have x is less than 6. We're using a parentheses because it's just less than, not less than or equal to. And so it's all the stuff to the left. And then x is greater than 9. So we start at 9 and we go to the right. Okay, so that means anything that's in either line is going to be part of my graph. So basically, I just graph, that's not quite on 6. Let me do it again. Okay, so I'm going to put my parenthesis on 6, and I'm going to draw my line to the left with an arrow at the end, meaning that it keeps going. And then this other line starts at 9 and it goes to the right. Now you'll notice they don't touch each other, they don't overlap, so this would not be from -infinity to +infinity. When we write the interval of this graph, let me go ahead and take away the stuff that doesn't belong, my scratch work. When I put this in my interval form, again, I always start at the left. So since this is going to the left towards -infinity, that's where my interval starts. And remember, with infinities, we use parentheses. So it starts at -infinity, and then it goes to 6, and then it stops. So we close that with a parenthesis. But it picks back up at 9, and then it goes to positive infinity. So we have, it looks like two separate intervals, but this is one graph, so we need to connect it. And the way that we connect it is by using the symbol that this word means. So if you'll remember in the previous lesson, our connecting symbol for and was the upside down U. The connecting symbol for or is the U. So since this is U, this is the union of the two intervals, we put a U in between these two intervals. And that's how we write the interval form when it's not connected and it's or. Sometimes a compound inequality that's connected by the word and will be written as one statement with no connecting word shown. So this is an example where we have a compound inequality where it's written as a single statement. If you'll notice, there's two inequality symbols. The goal here is to get the x, or the variable, by itself in the middle of the compound inequality. And the way that we do that is we're going to work with what's farthest away from the x first. We're going to undo addition and subtraction first. We have a minus 5, so we're going to do the opposite. We're going to add 5. But when we add 5 to the middle, we have to also do it to both outside parts. So I'm going to add 5 to this one, and I'm also going to add 5 to the negative 19. Okay, so that cancels. And we have a negative 14 is less than or equal to 3x, which is less than or equal to 6. So now the x is still not by itself. To get it by itself, I need to divide by 3. So once again, whatever I do to the middle, I have to do to both outside parts. Okay, so I have a negative 14 over 3 is less than or equal to x, which is less than or equal to 2. Now, trying to graph an improper fraction on a number line is difficult to do. Do you know where negative 14 over 3 is? Probably not. So let's change it to a mixed number. So if you'll remember, the way that we find or change an improper fraction to a mixed number, take the numerator and divide it by the denominator. So 3 will go into 14 4 times. That gives me 12. So then I have 2 left over. And then I put 2 over 3. So 4 2/3, well, it would a negative 4 2/3 is the same thing as a negative 14 over 3. Okay, so this is the compound inequality that we're going to graph. And the way that we graph this is we're going to start with the number on the left, negative 4 2/3. So that would be right in here somewhere. And whatever symbol is between it and the x, that's what we're going to put on that spot. Okay, so since I have that straight line underneath it, it's a less than or equal to, I'm going to use a bracket right here for the negative 4 2/3. And then it's going to go to 2, so I'm going to put a bracket on the 2. And x is all the stuff in between the two numbers. Okay, so if we were to separate this, let's talk about what it would look like if these two were separated. So if I had negative 4 2/3 is less than or equal to x, that's the same thing as x is greater than or equal to negative 4 2/3. So this part right here, x is greater than or equal to negative 4 2/3 would look like that, right? So this is the same thing as this part of the compound inequality. So then the other part of the compound inequality, the x is less than or equal to 2, well, we would start at 2 and we would go to the left. And so these two just connect. And so that's what we have on our line. We have negative 4 2/3, and it goes to 2. So that's what it's always going to look like whenever we have a compound inequality that's written as a single inequality. Our inequality symbols are both going to point to the left, and when we graph it, it's just going to be the stuff in between those two numbers. So the way that we write our interval form, we use a bracket. We always start at the left. We're going from negative 4 2/3, and we go to 2, and we close it with a bracket. All right, here is a compound inequality where we have x is less than negative 4 and x is greater than 6. Well, our connecting word is and, which means that we're only going to graph the part that overlaps. Well, let's see what these two inequalities look like separately. We have x is less than negative 4, so we would have a parenthesis on negative 4 and we go to the left. And then for x is greater than 6, we would start at 6, and it's all the stuff greater than 6, so we go to the right. So we have a problem here. And is only the stuff that overlaps. And we don't have anything overlapping in these two inequalities. So we wouldn't put anything on the graph. And we would say that our interval is no solution. There is no solution because there is no part of these two graphs that overlap. Okay, here's some compound inequalities that we have to solve first. So the first one, we have 3x plus 2 is less than or equal to negative 7. So to solve this, the first thing we would do would be subtract 2 from both sides. And that gives us 3x is less than or equal to negative 9. Divide both sides by 3. Should we flip the inequality? No, because we are not dividing by a negative. Only if we are dividing by a negative number or multiplying by a negative number, that's the only time that we flip the inequality. So this would be x is less than or equal to negative 3. And then for the other inequality, I'm going to subtract 1 from both sides, and I get negative 2x is less than or equal to 8. And then I divide both sides by negative 2. Do I flip the inequality this time? Yes, because I'm dividing by a negative. So we would change it to greater than or equal to negative 4. Okay, so our connecting word is or, which means we're going to put anything that's in either inequality on the line. X is less than or equal to negative 3. Okay, less than or equal to, we have that straight line, so we're going to do a bracket, less than, so that's what that would look like. X is greater than or equal to negative 4, so we start at negative 4 and we go to the right. Well, if I put these two together and put them both on the line, then they're going to overlap. One goes to the left all the way forever and one goes to the right forever. So that would be from negative infinity to positive infinity. And that would be our interval, negative infinity to positive infinity. Okay, I have one last example for you. X plus 2 is greater than 3, and 2x plus 1 is greater than 5. So we need to isolate the variables first. I'm going to subtract 2 from both sides. and that gives me x is greater than 1. Here we subtract 1 from both sides, and we get 2x is greater than 4. Divide by 2, and we have x is greater than 2. Okay, so if I look at these separately, x is greater than 1. We start at 1, and it goes to the right. And then x is greater than 2. We start at 2, and we go to the right. Okay, so when it's just the part that overlaps, when we look at just the part that overlaps, there's nothing that's overlapping between 1 and 2. But it starts overlapping right here at 2, and then it continues to overlap all the way to positive infinity. So that means we should start our actual graph at 2. We're going to use the same symbol for the line that starts there, which is a parenthesis, and then it's going to go to the right, to positive infinity. So my solution, my interval form of my solution, I would start with a parenthesis, and it goes from 2 to positive infinity, close it with a parenthesis. And that's how we graph compound inequalities. Thank you for watching.